Obrigada. So here we are again for the banca of the Defesa of Alina Dumas. Just like to thank Paul, Guilherme, Rafael for being here today. Really appreciate your presence here. The order that we will go in is Alina will start with her presentation. I would suggest then that the order for the Defesa, the Arguisao, can't remember how to say that in English now, that maybe we start with Paul as our most distant person coming from Scotland, then go to you, Rafael, and then to finish with Guilherme. For the part of the Arguisao, the procedures here, everyone has up to a maximum of an hour for each part, but obviously that's the max, that's a max limit, not an obligation. So feel free to use that time however you would like, whether you prefer to first talk and then pass over to Alina or to do more of a conversation, that's for each one. But I think we'll just get going with Alina's presentation. All good? Good luck. Thanks, everyone. Let's go.
So thank you everyone for being here. I'm here to defend my my PhD thesis, and my supervisor is Dr. Emer. My thesis was composed of 3 smaller projects. So there was a scoping review that aimed to evaluate how HRPCT is used when studying bone in loading and unloading responses. There was a systematic review that evaluated bone biomarkers. And finally, an observational study that aimed to study bone health in elite rowers. So first, we need a little bit of background. Bone is made up of the extracellular matrix, which has minerals, water, lipids, and an organic material. And that organic material is made up almost entirely of type 1 collagen, but it also has some other proteins. And there's 4 specialized bone cells. There's the osteoclasts, which are responsible for resorbing bone, osteoblasts, which are responsible for bone formation, osteocytes, which are multinucleated cells that make up the bone matrix and help in the response to mechanical loading, and bone lining cells. So these cells all take part in the bone remodeling cycle, which is made up of 5 different phases. So initially, there's an activation phase where a signal is received, and the bone remodeling cycle will begin. And this can either be a local signal, such as a micro fracture, or apoptosis, or a systemic signal, such as a hormone. Then there's the resorption phase, in which osteoclasts respond to these signals, and these multinucleated cells are formed to form this sealed zone that will protect the bone around it, where bone resorption may take place. The third phase is the reversal phase, which is a transition phase that forms this reversal line where osteoclasts will stop their function and osteoblasts will begin to form bone. There's bone formation, that's in which osteoblasts will form this new bone. And finally, termination, when bone formation is complete. And some of these osteoblasts will become osteocytes in the bone matrix. Bone has 2 main functions. It has a mechanical function as well as an endocrine function. Mechanically, it serves to support the rest of the body. It allows movement because it serves as levers and has the sites for muscle attachments, as well as protecting our vital organs. And as an endocrine organ, it serves to help in acid-base balance. It helps in mineral homeostasis because it serves as a reservoir for calcium and phosphate, and it also provides an environment where bone cells and blood cells can be produced in the bone marrow space. And one of the important functions of the mechanical part of the response is responding to mechanical loading. And much of what we know about mechanical loading was proposed by Harold Frost in the mechanostat theory, which actually builds on a previous theory that was proposed by Wolff, which is called Wolff's law. And it serves as a mechanical feedback loop depending on how much loading there is. And there's two important concepts. There's the mechanostat theory and mechanical loading, which is basically how much loading there is on a material and how this material can respond to those loads, as well as stress and strain. Stress is how much force is applied to a certain unit area, whereas strain is how this material will respond to that stress. So it's the amount of deformation that that material will undergo. And this is the graph that was proposed by Harold Frost. Initially, we have a disuse and adapted window where bone won't increase or decrease. It will decrease in the disuse window because there's less stress than there was. Whereas in the adapted window, it will remain fairly constant since bone is under the same stress that it's prepared for. Then there is the mild overload where bone is whether there is a small increase in the amount of stress that's applied to bone, and bone density has the ability to increase and improve. And finally, there's the pathologic overload window, which is where stress greatly increases, bone quality might decrease, and there is the risk of fracture. And this is important in order to be able to obtain our peak bone mass. So bone health throughout our life has three distinct stages. So there's the initial, sorry, can you hear me now? So there's the initial phase, which is during childhood and adult and our teenage years, where we accrue most of our bone. Then there's our midlife years where we try to maintain that bone. And then there's our later life, so probably around 40 or 50, where bone mass will decrease. And this decrease occurs faster in women than in men because of menopause and the fact that there's less estrogen being produced. And in order to obtain our peak bone mass, we need to make sure that we have these optimum lifestyle factors. If we don't reach those, if we don't have these optimum lifestyle factors, we're at risk of osteoporosis and a lower bone quality than we could have. And these lifestyle factors are ones such as nutrition, sleep, stress, and an important one is obviously physical activity. So this leads us, okay, there you go. This leads us to the three distinct evidence gaps that we identified. So initially, the first gap is if physical activity is beneficial for bone, why are athletes at a high risk of, oh, there we go, of bone stress injuries? And why are these so common amongst athletes? Second is, why are the effect sizes so variable and small? And thirdly, how do nutrition and physical activity interact? Which leads us to an important concept, which is energy availability, which is the amount of energy that remains for essential physiological functions after we have taken into account the amount of energy that has been used for exercise. And this we can have the optimum energy availability, or we can be in a state of low energy availability, where dietary intake is too low for the amount of energy that's expended. And there's two models that summarize the current understanding. There's the female or male athlete triad, and there's relative energy deficiency in sport. And both of these models have low energy availability as their central component. It's just that whereas REDS considers multiple physiological and psychological functions, the female and male athlete triad focuses mainly on reproductive health, bone health, and energy availability. One group of athletes that's at risk of being at low energy availability are rowers. Rowing is a cyclic, non-weight bearing sport, and workouts tend to be long and arduous. But there is a certain amount of muscle strain that could be applied on bone. The rowing stroke starts with the leg drive and ends with the arms. And there has been a few studies that have been conducted, both cross-sectional and longitudinal, but there's been conflicting results. Most of the studies that have been conducted on rowers have so far focused on DEXA, but there are other ways in which bone health can be evaluated. And this would be through the use of bone biomarkers and HRPQCT. So bone biomarkers are a dynamic measure of bone health, as they can tell you what's going on at the moment. So it gives you an acute response, whereas static measures, in this case, through the use of X-rays, give you a response, give you information as to the long-term response of bone. So this brings us to the aims and objectives of my thesis. The overall aim was to evaluate the effects of physical activity on bone health parameters, and this was done through 3 distinct projects, and each one with its own objective. So the first one was a scoping review, which aimed to evaluate how HRPCT is used in the study of physical activity and exercise, so how it's used in the study of the response to loading and unloading. The second one was a systematic review that aimed to evaluate how bone biomarkers respond to real-life endurance events. And the third one was an observational study that aimed to evaluate the relationship between bone and physical activity in rowers compared to a physically active control group, which brings us to the first project, which, as the title says, is the use of HRPCT imaging for the assessment of the skeletal response to loading and unloading. So far, most of the studies that have been conducted use DEXA. And DEXA is a very important tool. And so far, it's the gold standard for evaluating bone health. And it is what's used to diagnose osteoporosis. But it has 2 important limitations. It's a superposition of images, and it can't differentiate between cortical and trabecular bone, which is why HRPCT is important, because it can overcome these limitations and can evaluate the different bone compartments, as well as give us information on additional information that isn't available with DEXA. A scoping review is an important type of review that can be used to focus on a broad topic, and it tries to map the literature and establish gaps. And the idea is to identify articles and studies that have been published in this area, and try to improve and standardize what's known, and potentially identify where a systematic review could be conducted. HRPQCT so far is underused, but in order to use it better, we need to understand how it's currently being used. So the scoping review was conducted in this case because there was a great diversity of study protocols and study methodologies. So we considered it to be the best option for the study for what we wanted to accomplish. The idea was to map the existing literature on how HRPCT is used, and various sources were used to write the methods. These were the articles that were used for the methods. There's these 4. And additionally, we evaluated a set of guidelines that were published in 2020 by Whittier et al., which aims to standardize and improve the reporting of HRPCT outcomes. And this was endorsed by 3 important foundations. So the International Osteoporosis Foundation, the American Society, and the European Calcified Tissue Society. The aim was to assess how HRPUCT is used in the study of how bone microarchitecture and the long-term bone are affected by the relationship between physical activity and exercise. We developed a 6-stage strategy for this scoping review. In the first stage, we identified the aims and objectives. The second step was to identify the relevant studies, and we used the PCC acronym, so it's the Population Concept Context. Thirdly, we selected the studies, and this was done using a search string with the terms that we thought important, as well as searching for different databases. Then the data was charted using a spreadsheet, so all of the important data was extracted. Finally, we summarized and reported the results using either frequency counts, and these were visualized either narratively or visually. And finally, the results were analyzed and presented in tables or graphs such as these. Initially, we found 87 studies that could be included. So there was around 2,000 studies that were initiated. And after evaluating the abstract, the title, and the study itself, 87 were included in the review. Out of these 87 studies, 8 were review studies. So there was one systematic review, a few literature reviews, and the vast majority of these studies were actually observational studies, with 32 of these being cross-sectional studies. These cross-sectional studies tended to evaluate athletes and controls, and there was also a few large population studies, which were association studies. The important thing is that in observational studies, we cannot establish cause and effect. We can just establish relationships, and we would need more experimental studies in order to be able to evaluate these responses a little bit better. Experimental studies in this review tended to focus on women, specifically postmenopausal women, and there was a lack of studies in older men who are still at risk of osteoporosis and fragility fractures. Men and women were roughly equal in terms of representation. However, studies published on women there were more studies published on women than on men. And this was mainly due to the large population studies that were conducted on men and the small studies on elite athletes that were conducted on women. There was a focus on the female athlete triad in these observational studies. Large observational studies tended to focus on men, and experimental studies tended to focus on postmenopausal women. So the main finding here was that there was a lack of experimental studies and a large reliance on cross-sectional studies, which cannot establish cause and effect. And populational studies tended to be conducted on men, whereas cross-sectional and experimental studies tended to focus on women. HRPQT is limited to just evaluating the tibia and the radius, and it provides a large number of parameters. And close to 40 parameters were evaluated in the different studies, which limits the ability to compare these results. And there was a lack of standardization in how these results were presented and the methodologies. And we can see here, this is a graph of just the tibia, the radius at the 22.5 and the 4%, so the ultradistal tibia. And we can see that there wasn't a single study that evaluated all of these compartments, especially on the left, which makes it very hard to be able to compare the results obtained by these different studies. In the right, there were some parameters that were evaluated in all of these studies, but it was a very small number. It was only 9 studies that actually participated in that. The guidelines that were published in 2020 were not followed very well. There was only 4 studies that actually followed all of the guidelines. And we can see here that the total guidelines, so all of the studies and the number of guidelines that were published, that were followed, did not differ greatly from comparing before the guidelines were published and after. But this may be due to the fact that the guidelines were published in 2020 and possibly a number of studies were already being reviewed and had already been conducted when the guidelines were published. There are some things that you can go back and double check and maybe try to improve, but there are other things that cannot be sort of done after the study has been conducted. The one that improved the most is guideline 7, which is evaluating motion artifact, which basically evaluates the quality of the images. But even in that case, it's a very subjective thing. So it's just having people evaluate the images and rate them from 1 to 5. There is no standard way of evaluating these images. So future studies should aim to follow these guidelines as closely as possible in order to be able to compare these results and to be able to systematically review this information. And it could potentially aid in having more systematic reviews in this area. So in summary, this study aimed to evaluate the relationship between skeletal response and mechanical loading and how HRPQCT is used in that context. There was a number of different scan sites that were evaluated. Literature was limited by the predominance of cross-sectional studies, and future studies should aim to standardize protocols and reports in order to be able to compare results, as well as having more longitudinal studies and experimental studies. Another interesting point would be to correlate these outcomes with outcomes of acute response in order to improve our understanding. This brings us to the second project, which was a systematic review titled The Bone Biomarker Response to Real-Life Endurance Events, a systematic review of natural observational studies. So we know so far that bone biomarkers respond to exercise, and this response depends on the type and intensity of the exercise. A meta-analysis was conducted by a group which focused on lab-based studies. And this was a systematic review that was published. The results of this systematic review, the most important one for my study, was the fact that the bone biomarker response to exercise was time sensitive, and that CTX showed the largest response with longer durations and more work, leading to a larger increase in CTX. For my systematic review, we are basically assuming, the assumption that we made is that we would observe the same results in the real world. However, lab studies allow for a very tight control of variables and confounding factors. And in order to better understand real world events, these events need to be evaluated and the data needs to be synthesized in order to better get a better image of what's happening. The most important part here is that it's not confirmed as to how these bone biomarkers respond in real world events. We were just assuming that we would observe something similar to the lab-based studies. We picked observational studies in which scientists do not interfere, they simply observe and collect the data, and this helps us understand habits, patterns, and behaviors in the real world context. The aim was to evaluate the effect of endurance events on markers of bone formation and bone resorption through the use of a systematic review. We extended on the previous meta-analysis of lab-based studies, and the same methods were used. We used the same eligibility criteria, with the only difference being that we only focused on observational studies. A risk of bias was conducted at the end in order to evaluate the quality of these studies. And the important part here is that we're extending on the previous meta-analysis by evaluating real-world events compared to the lab events. We found in this systematic review that there tended to be a slight decrease in bone formation and an increase in bone resorption. However, we split the distances into 3 large groups. So distances that were less than marathon distances, and distances that were longer, so ultramarathons. And this response tended to be greatest in the ultramarathons for bone formation, as well as bone resorption. However, in bone formation, all of the large effect sizes were observed for a single study, which had a very small number of participants. And all of the other studies crossed the 0. So the results weren't as significant as we would like them to be in order to clearly say whether or not the bone resorption is greatly affected or not by these endurance events. For bone resorption, we can see, for bone formation, we can see, oh, sorry, that was bone formation. This is bone resorption. For bone resorption, we can see that it actually, there is a trend for an increase in the ultramarathon as well. And there's a few studies that focused on this. So this wasn't observed by a single study, and there were more participants. The other studies all crossed the 0, so it's the same thing. The results weren't as significant. But this is a bit more clear-cut. In cycling, there were only 5 studies, and only a single study focused on mountain biking. All of the rest focused on road cycling. There was 4 studies here, but all of the responses also, they're very, very similar to the mean from before the competition. So there wasn't much observed in this case. The overall discussion and results that we observed were that we may have missed, given the timings, we may have missed or they may have missed the highest points, the points of highest concentration in these bone biomarkers, given that they sometimes collected data every week or every couple of days, and they might have missed that important peak. The bone biomarker response during recovery is unknown because of that. there were close to 15, there were 15 bone biomarkers evaluated, so it limits our ability to compare these results. And few studies validated both bone formation and bone resorption, which would have given us more information as to the decoupling of these events. And nutrition was not accounted for. The summary of this solar project was that we aimed to evaluate the trends in the bone biomarker response. No consistent patterns were observed. However, there was a trend in running, specifically for the ultramarathons, so for the long distances, for an increase in bone resorption and a decrease in bone formation. However, the interpretation of these results was limited by the study methods of these studies. Standardization and control should be improved for future studies. And this could be done by having more information regarding nutrition, as well as evaluating the reference bone biomarkers, which are CTX and P1 and P. And an interesting thing would be to observe to monitor exploratory variables such as heart rate, stress, and other things that could affect bone biomarkers in a more of an indirect way. And future studies should aim to address these gaps in order to clarify how endurance events impact bone health. And that brings us to my last study, which evaluated the association between rowing and bone health in rowers in São Paulo, Brazil. So there was a cross-sectional study with a longitudinal component. And given the small number of athletes that actually participated in the longitudinal event and the fact that the results were very stable throughout the season, I decided to focus on the cross-sectional study for the presentation, as there were some interesting findings. So rowers are a group of athletes that are at risk of low energy availability, given the fact that there are high training loads, and rowing is a low impact cyclical sport. However, athletes in this sport do cross train, so there is a lot of resistance training, as well as the fact that there is a lot of muscle strain on the bones that could potentially help with bone density. So there are various mechanisms through which bone can be improved, and it's not quite known whether rowing will be beneficial or detrimental to bone. Previous studies have been conducted, a cross-sectional and longitudinal, but they have all been conducted using DEXA. There's none that have used HRPCT. And although HRPCT has been used in other sporting modalities such as skiing, running, and skating. And since HRPCT has the ability to differentiate between cortical and trabecular bone, it can provide more detailed information about bone. However, it can only evaluate those two peripheral sites. Cross-sectional and longitudinal studies have been conducted. However, results for the cross-sectional studies were conflicted. There's some that observed an increase in bone density, others that observed a decrease. So there's a possible redistribution of bone mass and a site-specific response. However, since results conflicted, this isn't quite clear. And a similar thing for the longitudinal studies. There were very few studies that were conducted, and there was a mix of levels of experience, weight category, and gender. So it makes comparing these results and trying to establish a more definitive answer a bit harder. The aim was to evaluate the relationship between bone health and rowing, as evaluated by HRPCT, DEXA, and bone biomarkers. This was a convenient sample of high-performance rowers that were all recruited at the High Olympica. Rowers had to train 6 days a week and have a minimum of 4 years of rowing experience. Data was collected during the mid-season for rowers, since that's when training tends to be more stable and loads tend to be higher. And bone health was evaluated using DEXA, HRPCT, and bone biomarkers. Statistically, a p-value was conducted, but instead of having a clear cutoff, there was a range, and it was a measure of the incompatibility with the null hypothesis. So if p was greater than 0.01, it was considered not significant, whereas if p was less than 0.001, it was considered a very significant response. And these athletes were tier 3 or tier 4, according to the McKay criteria, which makes this study a bit different, since most studies tend to focus on, cannot generally recruit athletes that are in this category. We recruited 20 rowers. 16 provided the DEXA, 15 provided HRPCT, and 17 provided blood samples, and 14 recreationally active controls. This is the data that compared the rowers to the controls, and we focused on the male rowers for the statistical analysis, given the very small number of female rowers. There was a large difference in height, a significant difference, but other than that, rowers and controls were very similar. When evaluating the bone biomarkers and bone density, there was almost no differences. However, we did observe a significant difference in the TBS so the trabecular bone score of the athletes, as it was lower than in the control group, as well as weak evidence of a decrease in rib bone density, which for rowers tends to be important because rib stress fractures is one of the most common injuries. When using the HRPQCT, we validated the radius, which found a significant decrease, not decrease, a significantly lower cortical BMD, as well as weak evidence of lower trabecular number and trabecular separation. And similar results were obtained for the tibia. There was a significant difference in the cortical BMD, as well as weak evidence of a thinner cortical thickness. And those were the most important results that we observed when evaluating the HRPCT parameters. So these studies suggest that participation in high-level rowing might be detrimental to bone health. It might negatively impact bone health. And this could be explained by a number of things that we couldn't quite evaluate. So future studies could aim to evaluate those. But it could be due to the loading patterns that are observed in rowing, a transient response in bone biomarkers that wasn't observed here, and nutrition factors. So this is the main summary, is that high performance male rowers, since the statistical part was conducted on male rowers, have similar bone mass. However, there is a reduction in some bone biomarker microarchitecture parameters, and future research is required to determine underlying and contributing factors to both the clinical and practical implications of these findings. So the general discussion and take-home messages are that this thesis suggests that in order to properly evaluate bone health, 3 complementary approaches are necessary. So the DEXA, HRPCT, and bone biomarkers should all be used in order to obtain information about body composition and bone mineral density at various sites, information about the different bone compartments, as well as the acute response to exercise. There is an incomplete picture of bone health if only one of these methods is used. And DEXA may not be sufficient to observe differences between groups. There were a few gaps. So overall, this study was limited by, there's limited longitudinal studies. There's a lack of standardization, and static and dynamic measures are not always integrated, as well as there being limited information about how acute and chronic responses are related and how the acute responses then lead to these, this chronic response and how it can lead to the change in bone mineral density. And there is limited evidence regarding bone biomarkers and microarchitecture. So this thesis was made up of 3 projects that used 3 distinct methodologies. So there was the scoping review, the systematic review, and the observational studies, and 3 ways in which bone health could be evaluated: DEXA, HRPQCT, and bone biomarkers. The scoping review suggested that HRPQCT is used more in the lab to evaluate bone microarchitecture, and it mainly focused on cross-sectional studies, which cannot establish cause and effect. The systematic review showed that bone biomarkers are able to evaluate the acute response to endurance exercise. However, it is unknown how these changes in bone biomarkers lead to changes in bone microarchitecture. And the rowing study used DEXA, HRPCT, and bone biomarkers, and was able to, and we saw that the DEXA on its own was not enough to observe differences, given that the density was similar in rowers and controls, but the HRPKCT parameters were different. And that's my thesis.
Thank you very much, Alina. So now we'll move on to the part of the Arguiso discussion, I guess. I would suggest we start with Paul, if that's okay. Is that okay with you, Paul? I don't know where to look.
Yeah, of course. Okay.
And I'm just gonna stop the. Just hit escape, hit escape. Hit escape.
And I think if you click the bottom, no, like the green thing, and you can go to share meeting or show meeting to the right. No, like right there. There.
Yes.
Yeah.
Like the background, Paul. That's Donata, right?
Yeah.
Paul is joining us from Scotland, but not actually this castle, I hope. So over to you, Paul.
Great. Thank you for the presentation, Alina. It was interested and enjoyed going through your
Hang on one
thesis.
sec, Paul. You're very, very low. I'm just going to see if I can increase the volume. Yeah, where was he? Where was he playing?
Any better?
Imer, talvez o áudio do computador, porque eu consigo ouvir bem ele aqui. Sorry, Paul.
Okay.
Meant to speak English. It's too early in the morning, though.
Right now. Go. Paul, could you say something again there? Let me see.
Is that any better?
And again?
Volume check. Is that okay?
Quite low.
Can you turn up the volume in the computer, Imer?
Is it just me? Is Guy coming through okay, or?
No, everyone's very low. Com licença, a áudio está muito baixa aqui. Não podemos ouvir bem. There should be the guys in the IT place should be along. They should be able to check it.
O pessoal da assistência pode dar um música o volume da sala, por gentileza?
Só um momento, estamos tentando.
Obrigado.
Eu acho que eu vi a cara dizendo que ali está. Paul, do you want to say something again there till we see how you are?
Você consegue subir um pouquinho o volume do microfone, você?
A gente nem pode te ouvir. O som não está funcionando.
Isso tem a... Um momento.
Paul, do you want to say something else there? We see.
Volume check. Is that got any better?
I believe the guy is on his way to
Tudo
fix it.
bem? Aqui é Orlando, apoio didático. Vocês estão com um som muito baixo aí, é isso?
Mas tem outro?
Sim. Podemos ouvir, mas muito, muito baixa.
Aham. E a minha voz, você está ouvindo bem?
Não, é muito baixa.
Tá ruim também? Tá. Eu vou subir aí para dar uma olhada, tá? Só um momento.
Ok, tá ótimo, obrigada. Paul, the guy is on his way. It's here right next door, so he should be quick.
Good.
I guess we could probably just go and. Can you hear us, Paul?
Yeah, you're coming through well.
Okay, let's just go ahead. I can just about hear you. The guy is on the way. Oh yeah, actually, that makes more sense. Let's just start with Rafael. The guy is already here. If it's a quick fix, we'll maintain the plan. If not, we'll start with Rafael. That would have made more sense.
Alguém do SAD pode falar?
Hello. Tá ouvindo? Tá alto, tá alto? Tá bom, tá bom. Testando, som, testando. Som, testando. Melhorou?
Não, ainda tá ruim.
Testando, som, vê se melhorou.
Melhorou.
Melhorou?
Aham.
Né?
Obrigado.
Tá bom, tá bom? É isso.
All right, we're back in action. Obrigado. Paul, over to you.
Professor?
Yeah, now it's us. Now it's good.
Thank you. I was just saying, I really liked the presentation, Alina, and also going through your thesis. So thank you. I was just wondering if you could start off by outlining kind of what motivated you to integrate the three different elements, the HRPQCT, DEXA, and biomarkers into a single framework.
Sorry, could you repeat it? It cut off a little bit right when you were asking the question.
Yeah, I was interested in kind of what motivated you to integrate the three different factors, so the HRPQCT, DEXA, and biomarkers into a single framework.
So my initial project focused just on the rowing study, and it was meant to be longitudinal, and it was meant to incorporate all three of those elements, so the HRPCT, the DEXA, and the bone biomarkers. But the project sort of changed halfway through, and I really, really enjoyed the HRPCT. I thought it was a very nice piece of technology that just gives us a lot of information. But because it's limited to only 2 sites, so it can only evaluate peripheral sites, it can't quite give us a lot of information about the medically relevant sites, which tend to be the hip and the spine. So I thought it would be a nice way to integrate to see if you can get information about the bone compartment, about the information about the medically relevant sites, which would be the spine and the hip, as well as maybe body composition, and bone biomarkers to give you a bit of an idea as to what's happening at that moment. And I thought it would just be interesting to be able to observe all of these frameworks in one single study.
If you were kind of looking to further develop that model, what else might you include and sort of why?
In a new study or in my own thesis?
Just, I guess, yeah, I mean, you've developed this framework. So you're saying these three different elements give you insight into, I guess, bone health and its sort of properties. So I'm wondering if you had more resources, more time, etc., what else would you incorporate into that framework?
I would Honestly, just try to incorporate more time points. Try to get more participants and more time points to actually see how bone will change throughout the years or throughout the seasons. Because getting just a snapshot of what's happening at one moment doesn't, I mean, it gives you a lot of interesting findings and interesting information if you can compare it, but it doesn't quite give you information as to the long-term response. If I had time, resources, people, I would try to incorporate all three into one single large, basically population-based study and try to separate the different types of loading. So sedentary people, people that do cycling and swimming and rowing, those that do fighting sports, and try to get a much better picture as to not only the parameters that are given by the different methodologies, but also what can be observed through different loading patterns.
And presume, obviously, the biomarker which you mentioned is the dynamic part of the framework. If you obviously you're capturing biomarkers over time in response to a stimulus. Just out of interest, how reliable is that, and how many times would you have to measure this profile across different exercises before you got something that was reliable?
I Ideally, you would do it, or I would try to focus on just, let's say, like one event, but try to get more blood samples closer together. So not just one every 3 or 4 days, but maybe get one before they compete, one after they compete, a couple hours after, and then maybe 1, 2, 3, 4, 5 days. So try to get more blood samples, but within a shorter time period to get a better picture, to be able to better graph these results. So bone biomarkers, because they respond fairly quickly and they are affected by food and circadian rhythm, they're a very interesting tool, but they're not as reliable if you just get a single blood sample.
Yeah, that makes a lot of sense. But I guess so. There you are, presumably envisaging this as a group effect. So if you have 20 people and you do that process you just outlined, and you maybe compare different exercise types, I guess, across those 15 peoples, you might have a signal.
Yeah.
So is that how you imagine it, or is your interest more individual? In other words, do you think that biomarkers will be very different for different people, in which case you need to build an individualized profile?
I think biomarkers are different, but I would initially focus on a group effect to try to get a better idea as to what's happening overall. And I would, if I had time and resources, I would try to get, 100 or 150 people, not just 20, to get a group effect, and then maybe try to spot the sports that have the most variability and try to see what's different amongst the different athletes in that sport. Because there might be sports that, because they don't have the limitations of being at weight or trying to, it's not a very lean sport, they may not be as affected by low energy availability or the lack of impact. So it might be a lot more consistent in that group, whereas people like triathletes or swimmers, it might vary quite a bit more depending on whether they do long or short distances, whether they have a certain, mental image of what they'd like to be. Or I would try to separate it first as a group effect and then focus on the sport that shows the most variability and try to identify what might be causing those differences.
It's really interesting. In your presentation, you mentioned kind of when you were, I think it was when you were discussing research conducted to look at the profile of bone health across athletes. You mentioned that effect sizes were really variable. And that was kind of one of the things that sort of initiated this project. So I wondered if you could just speak to that a little bit more about what type of effect sizes and kind of just outline how variable they are.
The variability depends a little on the modality. So I found that those like weightlifting and fighting sports tended to be less variable, whereas cycling and swimming tended to have very different results. So there's studies that would say like cycling negatively impacts bone, or others that might say there is no impact, or if there's resistance training, there will be the decline in bone density won't be as great. So the effect sizes varied by sport, and they tended to be small, but that might be a consequence of the fact that the time span of these studies tended to be fairly short. And if bone is already adapted to that sporting modality, it's going to be harder to see any changes in 6 or 9 months.
So I guess I wondered whether you would also, in your literature review, looking at sort of more consistent bone health. So you mentioned these sort of different profiles, so sort of strength athletes, mixed martial artists. Kind of what do you learn from that more stable bone health profiles, comparing different sports and their bone health?
From more consistent profiles, you can learn more about the site-specific responses. So you can see that in runners, they might have improved bone density at like the heel, and soccer players might have better bone density at the legs, but not the arms, or tennis players have increased density in their playing arm compared to their non-playing arm. So if the profile is more consistent, those changes won't be affected or shouldn't be as affected by these confounding factors. And you can get a better idea as to how that sport specifically impacts different sites. Whereas if there is a large, if it's very variable, or there are a number of other factors affecting it, which they always are, but they might be more or less predominant, you might not get such a good idea as to what's happening, because there might be like the body might be trying to make up for the lack of energy by decreasing the bone density. So you're not quite certain if it's the lack of impact, or if it's that they're not eating enough, or if maybe it's the muscle strain on the bone compared to something else. So I think that these consistent profiles give you a better idea, a better notion as to where specifically you can get these increases for that sport.
That makes a lot of sense. Thank you. So moving on to your scoping review, I wondered if you could just talk me through, just in general, what are the major elements that make a high quality scoping review to do for your review?
For me personally, or what I consider like a high quality scoping review? If I were to read
Yeah, the general principles that you can use to evaluate precisely whether a scoping review was conducted well or not.
Personally, for me, I would like a scoping review that has a clear aim, and within that aim, it's fairly broad. So it has the ability to pick up many different types of studies, not just like bone density in runners that have that are in a low state of energy availability. But it has a very, very broad concept as to what it wants to research. It's very clear as to what the terms are to incorporate studies in the scoping review. I personally would not limit it to a certain number of years. Like I would try to get everything that's been published on that certain topic. And also it tries to just say and discuss what's been published and what's been shown by the different studies, but doesn't come to a conclusion on its own. So it tries to establish these gaps. It tries to establish areas where there is a lot of literature and there is a lot of information, and just to state these things without coming to a definitive conclusion as to, let's say in my case, I can't say whether bone health positively responds to loading or unloading based on the scoping review. It just serves as an overview as to what's been done with that technology in the subject area that I'm interested in.
I wondered if you could kind of, in hindsight, after conducting your scoping review, kind of reflect on what you think was done well, and kind of if you had to redo it, kind of what you've learned and kind of what you would include this next time around.
I would, I mean, I learned how to properly systematically review these articles, but what I would have done differently is try to maybe incorporate studies, animal studies as well as human studies, because they can give you a bit more information, and maybe focus on less parameters. Just pick one site, pick a certain parameters that I find interesting or that should be focused on in all studies, and not try to count every single parameter that's been evaluated and how many times it showed up, but just focus more on a few certain things in the broad context of physical activity and bone. And I would, in terms of presenting the results, I would try to, there's a few things that I found interesting that I would maybe try to incorporate a bit more, specifically the correlation between the other measures that have been conducted and the HRPCT, which I just sort of said, oh, there's this many studies that also evaluated bone biomarkers, but maybe try to focus a bit more on those and what they were able to see that other studies couldn't see.
And obviously, you mentioned in your presentation that one of the principal elements of doing a scope written review is to identify what systematic reviews could be done next. So I wonder, kind of, obviously, you picked a specific systematic review, but based on your overall findings from your scope and review, what are other systematic reviews that you could have completed? In other words, that there was sufficient information, gaps, etc.
The only one that could be conducted is on athletes and cross-sectional studies, because all of the other studies were very, very variable as to what they reported. But the ones that were conducted on athletes, whether or not they had the female athlete triad, which tended to be one of the main focuses, or if it was just evaluating, I think there was a skating study that compared the landing leg compared to the other leg, that would be the only systematic review that could be conducted. For experimental studies and pre-post studies, there's the number of studies published is too small to be able to conduct a significant systematic review.
Yeah, so could you talk me through then the linkage of, when you're doing your project, you complete this scope and review, how does that link to your next study, which is your systematic review, which is
So the scoping review focused just on HRPCT and the static measures, whereas the systematic review just on the bone biomarkers. So it serves to show that there's two distinct ways that bone health could be evaluated, and that each one gives you important information about bone, but it doesn't give you enough information about everything that's going on. So the bone biomarkers give you very useful information as to what's happening then and how it's responding to that endurance event. And the HRPCT is able to give you information about how bone is responding long-term to, let's say, practice or their specific workouts or their routine. But neither one has the ability to show you the overall picture. So it was just to contrast both in both ways that bone health could be evaluated, and to try to start showing that even though they're very useful tools and they give you great information, more tools are needed or more methods are needed to get a better picture of everything everything that's going on.
Right. And I wonder if you could just talk me through kind of how you constrained this topic of biomarkers so that you could conduct a systematic review that was kind of consistent and to something of interest to yourself, because obviously it's a pretty large area.
The systematic review for the observational studies, these studies were initially included in the systematic review of the lab-based studies. It was meant to be just one big study, but there were so many studies in that we were able to identify that fulfilled the inclusion criteria that it ended up being split into the meta-analysis that was published, a second meta-analysis on nutrition, and then my systematic review. The methodologies were very different between the studies, so a meta-analysis could not be conducted. But this idea came about when we realized that there were so many studies in the original meta-analysis, and the fact that because these were different and their methodologies and their biomarkers were so different amongst each other, they couldn't necessarily be included in the original systematic review. There wasn't enough of those to be included, but there was enough to create this second smaller systematic review. And it was just a way to, since my original study was an observational study and it was similar to what they did in terms of bone biomarkers, I was able to conduct the systematic review to see if there were any trends in these bone biomarker response and endurance events.
So what goes into the decision? You said there that there wasn't appropriate, I guess, to conduct a meta-analysis, but you obviously you have forest plots, you've used some measure of scaling. So what is the decision-making process that says yes, it would be appropriate to meta-analyze, and no, it's not appropriate?
I think that it's appropriate to conduct a meta-analysis when the methods of the studies and the populations are similar enough that the results are significant. You can basically aggregate and compare them. In the studies that I saw, there was no studies. The cycling studies were similar enough. The 4 road cycling ones were fairly similar, but 4 is a very small number to actually get any significant responses for a meta-analysis. And for running, there was just too many distances that were conducted. It was both men and women. Some only had men, some only had women. So the answers, or if we were to conduct a meta-analysis, the quality of that meta-analysis would not have been very good given the diverse number of methods and study populations and people that were included. There was also a number of studies that lost participants because they might have flown back to their country after the race, or they couldn't complete the ultramarathon. And the timings were very different. So some had blood samples in the morning, some with nutrition, some without, some in the afternoon. So that would, all of those differences between the studies would make it very hard to conduct a nice, well done systematic review, a meta-analysis.
Thank you. So I guess moving on to the third study, I wondered if you could just talk me through kind of how this leads on to your previous 2 bits of work.
So this study leads onto the other 2 lead onto this because this study incorporates the biomarkers, the DEXA and HRPKT. It's the only study that incorporates all 3 of those. So the first 2 were to give us an idea as to what's going on with HRPKT and the bone biomarkers. And the third one is able to bring it all together as all 3 methods were used. It was a cross-sectional study, so ideally it would have been, all of the participants would have been able to participate in the longitudinal study to be able to get a nicer picture. But the distinction is that all 3 things were used, and it gives us an idea as to how we can use the 3 different methods and what information they can provide. So we saw that DEXA was similar between controls and rowers, but HRPCT wasn't. And it ties off the thesis because it's an original observational study conducted here, and it has all 3 technologies, all 3 methods were used to evaluate bone health.
Can you talk me through how you sort of determine sample size for this? Obviously, you're comparing to controls. So, yeah, just in general, how do you select a sample size to be able to address your research question?
For this specific study, I recruited as many rowers as I could in the High Olympica. There aren't that many rowers here, so it was a convenient sample, and I tried to recruit as many as I could. A few of them didn't want to participate, or they didn't want it to interfere with their practice, even though it didn't, but it doesn't matter. And the control group was based off of the number of rowers that were recruited. So we couldn't conduct a power analysis to see how many rowers we would need because we're limited by how many rowers are actually here.
Again, I guess a couple questions there. I guess the first one is, did you expect reasonable effect sizes or differences? So I know obviously you're saying that ultimately your sample size was based on resource availability, but do you have an idea based on what your initial assessments were, what type of sample size would have been ideal?
I can't say quite clearly, but definitely more rowers would have been needed to get a better response. Ideally, I would have liked to get 20 to 24 rowers to do all of the study, not just the DEXA or the bone biomarkers. But I'm not quite sure how many would have been ideal to, like, based off of a power calculation and to observe, ideal to sort of clearly see if these results are real or not, real in quotation marks.
Can you talk me through in your presentation? You discussed that you were using a inferential approach, which was around compatibility with the null hypothesis and not having a sort of binary classification. Kind of talk me through the pros and cons of that approach.
I personally liked it much more than just, the yes, no, because you're able to establish where maybe future research could be conducted if you had more people, as well as in our case, for instance, we had the trabecular number. So there were a few parameters that showed weak evidence of difference. But given that it was multiple parameters, you can suggest that there is in fact a difference between the trabecular boat in rowers and controlled. I think the pros of having this sort of compatibility with the null hypothesis allows you to see where you had actual significant results and where you might get interesting results that might not be significant, so that you might have just gotten that by chance, but they still give you additional information as to what you're trying to observe and trying to understand, to better understand. The cutoff, I think, is more significant, more important when what you're trying to establish is very important in terms of like life and death almost, or maybe not that drastic, but something that you need to specifically know whether or not you had an answer. In my case, it was weak evidence, strong evidence, very strong evidence of a difference. But I'm just comparing two groups, whereas in some cases you need to know whether or not that is in fact a significant answer. And if it's not, it's really not worth continuing to evaluate the other parameters, because you specifically need to see whether like a drug works or if it doesn't work, or whether a certain treatment was effective or if it wasn't effective. Can't really say it was weakly effective. Like someone wants to take a drug that's going to work.
Yeah, that makes sense. I wonder also how if these approaches differ based on whether your research is exploratory or confirmatory or somewhere in that sort of spectrum.
I would suggest, but I don't know statistics, that's you, that this sort of compatibility is more for observational studies or for these exploratory studies, whereas the specific cutoff might be more interesting for experimental studies, longitudinal studies that actually have a certain treatment plan or that are testing something that they need to be able to see whether or not it was effective.
And I wonder, just a final question for me is, rather than the sort of specific results that were significant or not, etc., the sort of general pattern of results that you obtained, is that kind of what you expected, or how confident are you, I guess, in the overall pattern of for this final study?
I was expecting a bit of a difference for the better in the lumbar spine, since that's where a lot of the stress and muscle action takes place in rowers, but it was actually worse than in controlled. And I was also expecting in the HRPQCT the legs to be a bit better than the controlled and the arms to be about the same, since the leg drive is what mainly, the leg action is what mainly drives the boat forward. But it was actually the tibia that was most affected, and it was the lumbar spine that was also most affected. So the results that I observed were the opposite of what I was expecting. I think that for the cortical difference, the cortical density, we can be fairly certain of these results because the p-value, going back to that, was fairly significant, but more athletes would be needed to understand whether the things that were weakly significant would turn into something that's more significant if we're able to get more people to participate.
Thank you for that. And again, really enjoyed reading your thesis, so thank you.
Awesome. Thanks so much, Paul. I think we'll now move straight on to Rafael. Okay. I think so. You might want to take this chair because there's chalk all over the place. Yeah, it's like a chalk explosion. Gold style. See what's doing all. Okay.
Hi, Alina. Hi, everyone. Can you hear me well? Paul and Guy. First of all, congratulations about the work. I really enjoyed. And my discussion with you here is I start from point of view of a colleague, but because I'm here, I'm duty to push you a little bit for your own thesis. So, and I must say that regarding bone health and bone parameters, um, you know way more than myself, and I think most of us in this room. So I will have some questions about specific stuff just to understand a little bit better. And I would like to start my discussion um, more related to the process rather than the work. And I could understand that at the beginning of your thesis, you were mainly focused on the third study, but that didn't work out. When you started that study, what were you thinking that you could get at the end? What was the main goal of that study when you started? Not when you changed path, but when you started.
So when I started, the initial idea was to do a longitudinal study. So I have, like, in my thesis, there's those 5 athletes that did complete the longitudinal part. So the idea was to just have a longitudinal study with all of the athletes, with the bone biomarkers, the DEXA, and the HRPQCT, in order to see if there's any changes throughout the season and to try to get more information about their nutrition, their energy status, their training. But the sort of pandemic struck in the middle. So, so that sort of, affected it a bit. And we changed it to the cross-sectional study. But initially it was meant to be just one longitudinal study focusing on those 3 parameters, as well as training load and nutrition, to try to see if there's also a relationship between those parameters and the bone response.
Right. And at the end, what were you expecting to give as a response for your colleagues or society in the end with your own study? What were you trying to answer? What was the main question when you started?
What I was trying to answer was if the fluctuations in training and in nutrition affected bone, how it affected bone, and if there was a difference observed, potentially suggest things that could be done to maybe to improve the response, or to try to limit the negative response if there was a negative response seen, to try to limit that negative response and preserve bone health as much as possible.
Right. And then because part of the introduction in your thesis, not in the paper, it's some few sections, but the main claim that I could understand is just studying bone health. It's relevant because injuries in sports, and then you start dig into that point, saying, okay, we need to study bone health. But the claim of injury was not really assessed in your third study itself. Was any historical background of injuries? Any participants had any issues? Or so that's the point that I'm trying to make when I start reading your thesis. Okay, the main claim here is just look at injuries in athletes. Man, why is that sound? It's
I
just
don't.
annoying me. Yeah, yeah. Anyway, but in the end, what I could understand was just that your thesis was most focused in the techniques, not really the injury itself. How you reconcile this, and what was your thought about it?
My original study would have tried to assess that a bit. There were a few injuries, me being one of them, a few stress fractures, which are fairly common in rowing. And then after I changed the study and incorporated the other ones, it was mainly to see if there's a better way to study and understand bone health in order to prevent these injuries. But I could have maybe incorporated that a bit better into the thesis. But that would have been the idea, to see how we can use these techniques and how these could be used to potentially try to either avoid bone stress fractures or try to understand if one might happen or might not happen, but it wasn't quite addressed.
Right. And based on the techniques that you have and the information that you have right now, if a colleague that rolls with you say, "Hey, Alina, how can I prevent my bone injuries?"
For my colleagues, I'd say I would suggest more high impact exercises, which is something that is lacking a bit here. So like running a bit more, or like box jumping, box jumps and box jumping. Cross training for rowing tends to be cycling quite a bit, because the the muscles that are used are very similar, which is another low impact exercise that, requires a lot of energy. So I would suggest more jumping and high impact exercises to prevent it. Rib stress fractures, which are very common in rowing, you can't quite do exercises to improve those, but you can improve technique and maybe certain things in the boat to try to limit the stress that the ribs feel, in order to limit stress fractures in that way. So stress fractures for, let's say, the hip or the shin splints, which are fairly common, those could be improved by doing more high impact exercises. And for ribs, it would be just improving technique and boat things like boat adjustments to maybe limit the stress on the ribs.
Yeah. And so based on your own techniques, you think that it would be feasible to tell your colleague or the population that rows, say, hey, you need to check your bone health, go for a DEXA scan, or go for a specific technique on your radius and tibia?
I would have said it a lot more to the lightweight rowers, but lightweight rowing is no longer a thing. Like it's not in the Olympics anymore. Gone completely. Starting 2024 were the last Olympics with lightweight rowing. They now switched it over to beach sprint, which is another type of rowing. I don't consider it rowing, but it's there. But that one has a lot more running. So it's like a very short race. It's 500 meters and you need to run a little bit. So these athletes do practice running. So it's just a new modality that's showing up, and it would be interesting maybe in the future to also get these rowers. But I would have suggested it a lot more for the lightweight rowers. For the heavyweight rowers, it would be interesting maybe, or if it's a rower that has already had a fracture, there's that, you can't quite determine if it was technique or if they might have something wrong, not wrong with their bones, but if their bone density might be slightly impaired. In that case, I would recommend it. But if that's not the case, then I think it might just stress the athletes more than it would help them.
Yeah, that's my point. From a practical point of view, telling someone to go for specific tasks and And then we go to your thesis that you have 3 studies. One is really specific for the architecture of the bone itself, and another one is more broad, and another one is sort of like bone metabolism. And for specific for rowing, what I couldn't understand, you have a dissociation of those techniques, which don't necessarily focus on the main issue of rowing itself, it's spine that you highlighted in one of those studies. Because in one technique, you just look at the radius and the tibia to not looking really the spine. And as far as I could understand your thesis, bone response from stress and exercise, it's really specific. And then on your third study, you're saying, well, the specific technique could see some differences, but you're not really focused on the spine, which is, or the ribs itself. And the other technique, which is the blood markers, is more overall and systemic. How could you tell someone that it's risk of spine fracture, which would impair exercise afterwards, would tell them to do those specific parameters in order to check their bone health?
So how I would tell someone to use specific parameters to evaluate their bone health?
Yeah.
I think that you could suggest that they could get their bone health evaluated if they thought it was interesting or if they were more at risk of injuries. But I don't think that's 100% necessary. I do think that if you're going to evaluate or if you suggest that someone evaluates their bone health, that maybe the DEXA and the HRPCT would be interesting because of the fact that you get different parameters. And even though there's not that many studies that correlate DEXA and HRPCT values, it's still important to know because you could potentially assume that if cortical bone is limited in one area, it is potentially affecting other areas. It might be affected in the hip or the spine. And if they also have a decrease in the trabecular bone score, which is like a bit more than DEXA, but not quite the HRPCT, then they are at risk of maybe having a poor bone quality in that area. So you would need both to see what's happening, and potentially you could extrapolate and say, oh, this is wrong here, so it might be happening here because we also observed it in the DEXA. And the bone biomarkers could give you an idea as to whether or not there is a fracture present. So if you see that there's no decoupling and the bone biomarkers appear to be fairly within range and normal, then so far there's nothing wrong. But if you do a blood test or if you evaluate the bone biomarkers and, either bone resorption is really high, something is clearly wrong, or if bone formation is very high, you could potentially think that there's a fracture somewhere and the body's trying to repair it.
Yeah, so the only concern that I had while I was reading and trying to put my point here is just, as far as you can understand, bone health is really specific. Like, for example, cyclists, I'm not sure what's the bone health in your femur or in your arms is like different. Yeah, I guess yes, right? And then that's the point. I was kind of missing this information, how to reconcile these 3 parameters and say, well, we found this differences in their bone structure in one technique, another technique show a different, and another technique show a different response. With that, how you put this information together for the specific sport of rowing, is that which I think is your main interest here. So just pushing a little bit to think about and reflect about this while reading your thesis. I think that could be more explored a little bit. Okay. Going forward, let me just turn on my computer here because I have some very few other questions about terminology itself. When you say real world, I understand that's exercise outside of the lab,
Yes,
but the lab is still real world, I guess.
true. Yeah.
Yeah. So that was a little bit, it's not a video game in the end, but so it's still real world, but maybe the wording is a little bit different from. But this is just about style. Couldn't definitely understand what you're saying. And another question I had is, there's this theory about mechanostat and mechano. That was the two different theories about
Mechanical loading.
mechanical loading. There you go. Those theories were based on a healthy bone, or there's also another step looking at the bone that's already fragile.
So the mechanostat theory sort of works off of Wolff's theory, which is Wolff's law, which, they sort of build on each other. And the mechanostat theory just focuses on this feedback loop that would either help increase bone density or decrease. It doesn't quite focus on other states, so like sick bone, let's say, or bone with osteoporosis. It mainly focuses on how mechanical loading, so the stress that's applied to bone, could potentially change the bone density given whether bone is already adapted to that much stress or not. So it just focuses on mainly healthy bone and how mechanical loading would affect that. There is that part of the graph that focuses on like a pathological load, so it could cause a fracture, but it's not like a bone with osteoporosis. It's a normal bone that would undergo a significant stress much, much higher than it's used to, and that would lead to fracture.
Yeah, because I was thinking, would that graph change slightly a bit if you use a different sample? Yeah, yeah, exactly. Because that would happen in different other tissues in the body. Like the mechanical strain or stress that you can absorb is totally different when you're fatigued or you have low energy availability and those things, right? So I'm not sure. It's just a question just to maybe reflect a little bit. And I guess there's nothing on that side so far in the literature.
Not quite, because when they studied it, they actually apply stress onto the bone. So there are a few studies that did grab, cadavers and actually compressed bone in the different axes to see how much they could tolerate. The one that I saw focused on spine samples, but you depend on, bone biopsies or actually being able to obtain a piece of bone to create that graph. I couldn't find anything in the literature that has that type of graph. But I think if it were a different sample with like osteoporosis or maybe cyclist, that graph would change a little bit, especially if there's, decoupling, so bone formation and bone resorption are not as coupled as they could be. So it might lead to, even though there's a nice overload that should lead to an increase in bone density, it might not increase or it might even decrease because there's these other factors that are coming into play, or there's like bone resorption or these processes are decoupled. So bone resorption might be higher and you might not be getting that increase that you would like to observe when there's a slight increase in mechanical loading.
Right on. So I'll go a little bit further in those specific questions of each study, just to wrap up. Because again, what I couldn't understand reading your thesis is that you do like bone and writing about it. When I opened your file, I was like, whoa, that's huge. And no, that was great. That was great. That was really nice, well written. I spotted some few typos
Yeah, I
throughout,
did too.
right? Yeah.
Horrible.
I
I
highlighted
would
it.
fix
No, it's all good. I highlighted and which I think was a positive thing because it shows me that you did not use ChatGPT to write.
No.
Yeah. So I was happy to see that actually. So I highlighted and I can forward to you the PDF with the highlights so you can spot the ones, and some citations I think was misplaced by the software that you're using. So I can definitely send that to you. And for project one, study one, did you register your scoping review at some point? Because I saw you register your systematic review, right?
Yes, the scoping review was not registered.
Right. Any specific reason for that?
It's not quite needed for a scoping review because you wouldn't, the idea of doing that for a systematic review is that you don't change your answer halfway through based on what you find. A scoping review is just meant to map the information and tell you this is what we have, this is what we could improve, this is a nice set of article that could potentially be used for a systematic review. And ideally in a scoping review, you're actually we're trying to, search those websites all the time and incorporating more studies as you find them. But since you're only trying to map the information and give an overview as to what's known and you're not coming to specific conclusions, registering it is not necessary.
Right, because I think JBI, the one of the guidelines that we follow, I think they have a registration thing, as far as I know. Their own registration.
I didn't see that, but so good.
Yeah, just if you go to Faculdade de Saúde Pública, they have people that work with JBI there. Yeah, you can ask. I mean, too late, but and other steps that you must check that. And I had a few questions about how did you manage the duplicates in those Scopy review?
How I got rid of
Study.
the duplicates or how?
Yeah, how you got rid of it?
I did the first part with Jercio. So we did we used the Ryan software to go through the articles, and then the Ryan got rid of some duplicates, and then it didn't get rid of all of them. And we manually got rid of some of them going through the articles that were then like sort of separated from the 2000. And then we reviewed the abstract and the full study to see which ones were incorporated. But I did that whole first part with Jercio. And then the data extraction, I did on my own, but he started it. So the idea is to then compare my extraction with his to see if there's any differences.
This is working pretty well, yeah. And yeah, because I have used different software, so I didn't see how you specify how you got rid of the duplicate. So I was just wondering. I do know that the Hyliion had some features, but I haven't ever explored. And in the end of project one, is the guideline really necessary? Because I saw that only 4 papers followed the right guidelines, but the rest didn't. Do you think that it's going to be mandatory, or you see the necessity of using it?
I don't think it'll be mandatory because that would limit the number of studies that are published because some people just want to publish what they want to publish. But I would highly suggest it because there's a lot of studies published on HRPC, and if these things, if were standardized, so like the motion artifact, which is one of them, or getting a certain amount of overlap, if you have a longitudinal study, would allow more studies to be compared rather than just having these one-off studies that they're very nice, they have nice results, but they can't quite be compared to other studies because they just published, the number of trabecula that are present in bone. But I don't think it'll ever be mandatory. I would like it to be followed. I would like the guidelines to be followed so that we can get more studies that are better sort of more studies that are within these parameters so that they could then be compared and you can get a better idea as to what's really going on if you have more studies that see the same thing rather than having one study that used the exact same technique, but they just focused on cortical bone, or another one that just focused on both strength, or another one that just focused. It would give us a better idea. I would also like to, if someone would create like a database, so you can publish, even if you don't publish the results, you can at least incorporate those main ones that I had on the graphs for everyone that works with HRPC, so that at least we start creating a database with these values.
Did you follow the guidelines?
For my study?
Yeah.
I found that article after I had
Right.
already started. There was overlap though. I looked afterwards. There was enough overlap. So there was like 80%. I knew that one. But the motion artifact, like Lillian sort of checked, but it wasn't, let's have these images, we'll have 2 people evaluate them, give them a score from 1 to 5. It could have been done a bit better. So the guidelines could have been followed a bit better in order to improve the quality of my own study.
Right. And then project 2, I saw that specific for running because it grabbed my attention because I like more running than cycling. So I just focus on those graphs. I remember that few studies there did not cross 0.
Yeah.
And then you rely a lot, your discussion based on those studies, saying, yeah, well, few studies did not cross zeros, therefore you can say that bone modeling or resorption was slightly different or not. The main issue here that I see is you have three different categories of running, like less than 42, the marathon, and above. But that analysis just focuses on the event as far as I can remember. So you're just looking at the blood markers after the event.
It depended on the study. There's a few studies that had bone biomarkers during the event, like the ultramarathons had bone biomarkers during the event, but that's because they were very long. It was like 200 kilometers, or these very, very long marathons. So they would pick checkpoints and they would collect samples at those checkpoints. But because it was at specific locations, those blood samples were at varying times of days depending on when the person got to that. For the marathon and the 15, like the less than a marathon, it was before, after, and maybe a few days after, but not during.
Okay, and just to refresh my mind, because I don't remember it quite well, on those forest plots, did you graph also the information before the event?
Yeah, so the before the event would be like the zero line.
Right on. So how much you think that the event itself is the only factor representing the bone modulation in the circulation itself, like the markers there?
During the event or like in general?
Yeah, because my point here is I have different distances and I'm looking at one single event. But I assume that the person did not just wake up and went for the event. They have some training schedule before. So that picture that we're seeing during the event is actually a picture of what they did months before. And I don't think that was touched in the discussion itself, because the training schedule for a person who's running ultra marathons is way different from a person who's running less than a marathon, like the time commitment, the duration, the intensity, and so on and so on. And what I can see is just that whenever you go above 42K, there's like more pronounced response of bone markers, right? So I don't think it's just the event itself. I think it's also the training schedule, what you try to address in your third study. But that discussion wasn't really touched at all in your study. So that was my concern. That, well, you just see a picture of the whole film, and it's hard to make assumptions based on only the event itself. Um, Maybe something to explore at some point, right? Um, Finally, going for the third project, I think we have discussed a bunch, and I think it's the main project that you liked, and that's very unfortunate it cannot progress more in the sample size itself. The only question I have, and then I would wrap up, is I saw that you calculated the energy expenditure for the training based on the training logs, and the way you did it, you calculated the METs. How did you calculate this?
There's the Mets have a publication with the conversion for a number of different sports. And in those sports, you have like rowing at different speeds. It's not just rowing. And I calculated the duration of practice, their weight. I had their weight, I had everything. And then I would use that Met score to convert it to calories. So it's not the best system. Ideally, it would have been like with a heart rate monitor, but not enough athletes actually used like wore the heart rate monitor to get that information. So I had to rely on Mets.
But even with heart rate, what would you change on those calculations?
With heart rate, you might be able to get it's not perfect, but you might be able to get a better number, a better amount of calories that were expended during practice. Because for instance, for the Mets, it's at certain speeds, but the speed that I row at is very different from the speed that a man rows at. They row faster, so the amount of energy that I would expend rowing at that pace might be greater than the amount of energy that someone else uses up. So it would give me a bit of a clear picture as to the effort that they put into that practice and how much energy was expended rather than just using these general numbers that are in the METS tables.
But even with heart rate, what would happen if I'm rowing at a constant load for 30 minutes and I'm using the gas exchange mask, right? The gas analysis. What would happen with VO2 at a constant pace in the moderate domain and heart rate? Do you think that what would happen with the heart rate throughout that exercise bout and the VO2?
They would both increase throughout the exercise bout. As the athlete gets more tired, heart rate should increase and VO2 should increase as well. And as they get more tired and those values increase, the amount of energy expended is going to vary based on how high, like how low you start, how high you get at the end, and how fast you get there, because you might go from 0 to 100 in the first 2 minutes and then stay up there for the rest of it, or it might take you 20 minutes and then just 10 minutes at that higher intensity. So I think both would increase throughout the bout.
Even in a moderate domain?
Yeah,
So, yeah,
even in a moderate domain, they would increase. Not as much, but it would still increase a little bit.
just for 30 minutes.
Yeah.
Okay. Then I think you have an issue in calculations with the calories, right?
Yeah.
Because even if I stay seated and then like a simple example, like taking this example of 30 minutes, what would be expected in the moderate domain when the characteristics of the VO2, which is the main variable to calculate calories expenditure to exercise, is you just expect to be stable throughout exercise after 6 to 5 minutes. You can definitely expect a slight change if you push for hours, but heart rate would slightly increase. So you have a kind of dissociation, a decoupling of those two variables. And as far as I understand, that is one of the issues to calculate energy expenditure because it's so hard. We cannot put a mask there and see how much energy they expenditure. And the other methods are really expensive in order to track their metabolism throughout the day or something like this. And heart rate is a nice way out. Still not perfect. Yeah, but it's not the perfect one. And maths, then I'm not sure. I need to dig in more and study how that one were calculated, how many samples they had in order to see the right amount of VO2 based on that speed, and if that was controlled by the energy domains of each participant, so it's go all over the place. So one thing that I was missing in your discussion is to touch on these calculations and how you put that in the picture when, because energy availability, as far as I can understand, for bone health is very central. And if you miscalculate how much energy you're expending, then you have something to put in your limitations in their study, as far as I can understand, right? So that was missing a little bit, was just there in the methods, and then discussion was around this, but I could not find a lot of information. Like, well, this is how we calculated, this is how the literature is calculated. Maybe we can progress more on this in order to have more accurate responses. Maybe something to dig a little bit more, or even bring people to the lab, make a rowing session to see how much energy they had, and maybe see if the literature is actually right in their maths calculation based on the speed and stuff. Anyway, so yeah. Yeah, exactly. And it's hard to measure in the end, right? Again, so I want I will stop here because I think it's way enough. And Guy is still a lot to ask for you. My final speech is just like congrats, really nice, really interesting. I'm happy to chat more if you want about these and those points. And the last question: did you enjoy your process?
I did it. There were a few, bumps in the road, but I really enjoyed it. I liked the reviews. I didn't expect to like them as much, but I really, really liked conducting the systematic review. I thought it was very interesting, and I would like to do a few more of those. And my own study, I did not like dealing with people. That was not for me. But I loved it. And I loved the, like, actually seeing the scans and the DEXAs and the HRPCD. I thought it was very, very interesting. I had a really good time.
That's good to hear. It's nice. Good. Yeah, because sometimes the PhD process is like always a struggle in the end. But congrats. Very, very nice. And that's all for now.
Awesome. Thank you very much. Well, some really, really interesting stuff there to think about. And now, last but certainly not least, Guy, can you still hear us? Are you there?
Yeah, definitely.
Yes, we can hear you.
Okay. Rafa, I'm sorry to disappoint you. I don't have much to say. You guys hearing me?
Yes.
Sorry, Guy. Yeah, go ahead, Guy. We can hear you. We were just bringing up so we could see you too.
Okay.
Now we can.
So, Rafa, sorry to disappoint you. I don't really have much to say. After nearly 2 hours of discussion, actually, you guys know bone is not really my expertise area. So I'm not going to be able to go deep into the scientific questions as Rafa and Bo have done. Just going to go through some of the details of your thesis, Alina. Well, first of all, I wanted to just say how much I enjoy your presentation and how much I enjoy the way you answer the questions and the way you stood up for the questions and for the discussion. I don't think I ever had the opportunity to talk to you very much.
No.
So you're very eloquent. So that was really impressive how eloquent you are when discussing your data and in your presentation as well. So congratulations on that. So on a general evaluation of your thesis, I think overall it's well written, it's well prepared, but I think there are a few bits and bobs that could have been improved. I think the style sometimes could have been improved. A few sentences you repeat a few words. Some other sentences sometimes they are overwordy. They could have been more concise and more straight to the point. There are a few typos here and there. So the impression I have is that the thesis didn't go through a thorough review. For example, there are things like bone instead of bone, like a double O. The word principles with an L instead of principles with an E. There are a few refs that you left in the text instead of adding the references, you left the refs. There is on page 62, you mention figure X. I think you're supposed to mean figure 3.2. Sometimes you define abbreviations more than once in the text. Think like HRPQCT. So the definition of the abbreviation appears like through 2 or 3 times in the text. So all in all, I think overall the thesis is well written, is well prepared, but I think it needs a review before it goes as a final version to the Faculty of Medicine.
I was planning on reviewing that. Like I do want to go through a last revision and incorporate all of the suggestions that I get here.
Okay, right. If I'm not mistaken, you show the summary, like a figure or table, showing the summary of the studies included in your systematic review before the chapter systematic review. I think so. You included the figures before starting the chapter, which
Oh, okay. I'll fix that.
is a bit strange. So I think that also needs attention too. You mentioned when you're doing your, I think your scoping review or maybe your systematic review, I don't quite remember now, a before slash and slash after type of study. What do you mean by that? Is that a crossover study? What exactly is a before and after study?
Pre, post, or before and after is a study where they measure, since bone health takes quite a bit of time to actually see changes, it would be a study where they measure, it was in the scoping review, the bone parameters, so they might get the scans before the study, then conduct any type of experimental study. Usually it tended to be like jumping studies. So they would like hop on leg. And then at the end of the study, they would repeat the HRPCT to compare the values before they did the intervention and after the intervention.
Is that with a control group?
The control tended to be the other leg, but some had a control group that didn't do the intervention, and they would get the scans at the same time. So before the intervention and after the 3 months or 12 weeks or however long the intervention was.
And how is that different from a control trial or uncontrolled trial that you also classify in your review?
A control trial usually had an intervention that was designed by the scientists, and a pre-post tended to be maybe, oh, that's, I could explain it better. It tended to be an intervention that more like an observational type of study. So it was
Yeah, that's what I was wondering. Like, this is an observational study, not a before and after study, if I'm not mistaken.
it's an observational, like a longitudinal observational study.
Yeah, that's what I would say.
Yes. Yeah, yeah.
I think there is a more clear classification for this type of study.
Okay.
Because before and after could be lots of different things. It's not very clear or specific. So in your figure 3.2, I think this is already a systematic review. You mentioned that 1,509 records were excluded, but I'm missing the reasons why they are excluded. I think they should have been in your in your figure, maybe. I don't think they're there.
The initial, they were excluded mainly for, because they didn't have HRPCT or a physical activity intervention.
Yeah,
But
I think you
I-
should include the reason for exclusion.
Yeah.
Just
will-
to be more transparent. On page 64, when you mention the country of the studies, US appeared twice.
Yeah.
Page 100, you mentioned something like a secondary analysis of natural experiments. I didn't quite understand what you mean by that. What would be a natural experiment, like an observational study?
Yeah, it would be an observational study without the interference based on these endurance events.
Okay, in this case, I wouldn't use the word experiment because usually experiment relates to when the researchers manipulate something.
Yes.
like some variable. And if you're just observing the natural course of events, I wouldn't use the word experiment, just not to cause any kind of confusion in the reader.
Okay.
In your forest plots, I think it would be easier to follow if you indicate which side favors formation or favors resorption. Like when you look at the bottom, like just underneath the horizontal axis, I think you should indicate which side favors what.
Okay.
What else? In your experimental study, I was really interested by your experiment in your experiment. But I had the impression that you kind of got disappointed with how things went. Is that true?
For the observational study?
Yeah, for the study 3.
A little bit, because I would have really liked to have been able to conduct the longitudinal study on all the rowers. So that was because I really like cross-sectional studies. I think they give a lot of valuable information and they're much easier to conduct because it's just that one time point. But I think the longitudinal study would have given a lot of valuable information that we didn't quite get because we couldn't conduct it.
Yeah, so tell me about the difficulties you had in conducting this study.
Recruiting rowers wasn't all that hard. There's just not many of them because I row. So I was able to go to my teammates and the other clubs and ask them if they wanted to participate. There weren't that many rowers over the age of 18, which is what we focused on. So I tried to recruit all of the ones that there were. And then after I spoke with them, some of them decided not to participate or they stopped rowing or something happened. And I had a lot of trouble with the controls. That was my main difficulty with the control group.
Really?
So yes, I do not like, I do not get along. Like it's my difficulty. I don't like randomly talking to people.
Okay.
Juliana helped me quite a bit there. She would go to, random tips like, hey, do you want to participate in my friend's study? And she was able to recruit the controls. But that's something that I had a lot of difficulty with. And if I were to conduct an observational study similar to this one, I would definitely get someone to help me recruit controls and athletes from the very start. So that would be something that doesn't limit the study as much as I think it did in this case.
Do you reckon statistically speaking, the universe was a limitation for you to recruit a larger sample size of rowers?
Yes, there was definitely a limitation. There's not that many high-level rowers in São Paulo. I recruited all of the ones that there were. Most of the rowers in Brazil are in Rio. So if this study had been conducted in Rio, there's hundreds of rowers there that could have been recruited, but it's not the case here. So it
Did
was,
you consider a move to Rio for a few months to increase the sample size
I thought about it.
out of the table?
I thought about recruiting them, and we had a competition here. But I never went through with that. But it would have been interesting to get the Rio clubs because Botafogo, Flamengo, and Vasco da Gama have they all have very large teams.
Okay. Yeah. So I was wondering, like when reading your review, like it seems clear that the major gaps in the literature, in addition to, of course, the differences in techniques and methods, etc., which is natural for every area of study. But it seems like the main problem is that the difficulties in study bone, the long-term nature of bone turnover and etc., and limitations in sample size, difficulties in approaching high-level athletes and etc. So if you're in São Paulo, São Paulo is the third, maybe fourth now, population in the world. This the biggest city in terms of population in the world. And yet you can only recruit 20 rowers. Does that mean that the literature is unfixable? Like we're never going to be able to have a large enough and long enough study with real high level athletes. to measure like bone in a specific sport? Is that how you see it? Because it's how it seems to me when I read your thesis.
No, I don't think. I mean, if one person were to conduct it here, I think it's sort of what you have. But if the possibility arose to conduct this study with other countries and other clubs and other states, that would greatly increase the power and it would help to have more people and a larger sample number and more athletes. But it would definitely need to be like a multinational, multi-central study. I think that for many sports, for most sports, there is usually not enough athletes in one place to be able to conduct a significant study. So if you can conduct it with other countries that also have HRPCTs and then maybe use like a phantom limb to try to compare results so that you make sure that, 1.7 in Canada is the same as a 1.7 in Brazil. Then you could conduct one of these studies and get a much clearer answer. The universe was definitely limitation here. There's not that many clubs, there's not that many rowers. If I had picked another sport, maybe I would have had more athletes, but then they still, need to want to participate and come to go to AFA to get the blood samples or come here to get the scans done. So it's definitely a limitation, but it can be overcome by working with other countries or other universities or other states.
And have you considered expanding the scope of your universe, like going beyond rowers only and including other similar sport modalities like kayaking or I don't know, whatever other modalities that have similar characteristics to rowing, just to increase your sample size? Did you consider?
I thought about it, but I never actually discussed it because the main idea was to study the effects of rowing. There aren't that many sports that are similar to rowing because even kayaking, you're in the boat on the water. But kayaking uses their trunk and arms far more than rowing does, whereas rowing uses the legs a lot more. The most
It's my ignorance. I don't know the
no,
modalities.
everyone says, "Oh, you row, right?" It's like, no, it's not quite like that. Lots of
Yeah,
arms.
that would be me. That would be me.
But I I think it would have been nice to like include cycling, which is a similar sport, or even skating, like skiing. Cross-country skiing is very similar to rowing in terms of muscles and loads that you could include. But it also would have decreased the ability to see things in rowers if you include a number of different sports. And I was interested in rowing and what happened to bones in rowers and devaluing their bones.
Okay, right. Do you reckon these difficulties you had in recruiting people and keeping them in the study, do they affect the quality of your data, or not the quality of your data, but your ability to make like conclusions with a certain levels of certainty?
I think it definitely did. I think if I had been able to maintain them, or if they hadn't stopped growing, or for whatever reason I didn't get all of the scans, if I had gotten all of them, I think it would have increased the reliability of the results because everyone would have all of the scans and all of the blood samples. So it would have given a bit of a more reliable result. But I don't think that the results that I have are unreliable. I think that they are nice results, but with a larger sample number and if everyone had stayed in the study, they would have been just a bit more reliable.
Yeah, maybe reliable is not the best word. I was meant to say the strength of the evidence or
Yeah,
something
it
in that direction.
would have been stronger then. The evidence would have been stronger, and maybe the weak differences that we saw would have been a bit more clear, either in either direction. It would have been stronger evidence towards like lower mineral density in the ribs, or maybe it would have gone the other way and it would have become weaker and it would have been non-significant. So I think it definitely would have helped in that case. But I think the results as a starting point for rowing with HRPCT, with DEXA, and with blood samples are a very nice starting point for people to continue and expand on it if they were interested.
Okay, speaking of which, speaking of strength of the evidence, and that's my last question. I noticed that you use a kind of a classification system based on the p-values. So if p less than 0.1 to 0.05, that's weak evidence, right? If it's below 0.05 and 0.01, 0.01, it's I forgot how you classify that. And like the lower the p-value, the stronger the evidence. I've been reading like lots of criticisms of decisions of this strength of the evidence based on solely the p-value. And I was wondering how well accepted is this classification? Why did you decide to use it?
This classification has been used in previous studies. I don't quite know that much about it, but it was used because of the fact that we were trying to identify differences between the controls and the rowers. And by having this sort of compatibility with the null hypothesis would give us a bit more of an idea as to differences that could be observed and maybe something that is interesting but might not be as strong as other points that we're seeing. But it gives a bit of a range as to start seeing some differences that they're interesting, something might be going on there, and things that are a bit more significant, such as the cortical differences. I don't think a specific cutoff would have been ideal in this case because it was an observational study and I'm not trying to prove that, you know, this intervention helped. It was just to observe differences between the two groups, and this would give us a better idea as to what differences are significant, which ones aren't, and which ones are interesting, but maybe if you accumulate a bunch of weak evidence, then it becomes something that's a bit more certain, such as the trabecular number and trabecular separation. And those three parameters or those two parameters for the trabecular bone were different in the rowers and controls. So that could lead to the suggestion that trabecular bone is affected, even though it's weak in terms of the p-value.
Okay, yeah, I tend to think it's the same way you think, so I kind of agree with that. I think this is all I have to add in my part. Just wanted to thank you and Emer for the invitation. It's very good to be here with Paul and Hafa. Very good to see you guys. And Emer, I pass it over to you.
Great. Thank you all so much. Guy, we'll have to have a chat about that at some stage. I admit I was the one that pushed for I like the more flexible strength of evidence or certainty, I think is the preferred. But I'm aware it's very much debated. So obviously Paul is somebody else who'd want to pull into that discussion, but that's a conversation for another day. I just wanted to follow up on one thing that Alina briefly alluded to, but didn't really come in. The focus on rowers. I think it's worth mentioning that Alina managed to conduct this entire study during a very, very busy few years. Alina herself is a elite rower. She represented Paris in the Paralympics last year. As soon as she had submitted her thesis this time, she hopped on a plane to Shanghai to go to the World Championships. So, and in the middle of all those very, very positive things, she also faced a number of injuries, surgeries, and kind of health problems with her legs as well. You can see she's on a crutch here. She had surgery last week. So there was certainly there was issues with the recruitment, but I also think it's a very strong reflection on Alina that she made it here. She's here because it was a busy few years. At this point, I will ask Alina and Max to step out for a moment, and the banker will deliberate, and then we'll call you back in.